Assalamu alaikum. Welcome, students. In the last lecture, we explored the concept of transfer function in detail, and we started the topic of electrical system transfer function. Uh, we then finished doing a simple problem related to the electrical network. Uh, let's start. Today's lecture by summarizing the problem we have done in the previous lecture by highlighting the steps we followed in solving this problem. So, uh, the first step was redraw uh, the original network showing all time variables such as v of t, I of t, etc. As Laplace transforms. V of s, I of s, respectively. The first step we did was to convert this circuit and variables v of t and I of t and vc of t into their Laplace transforms vi of s, I of s, and vc of s. Second step is replace all the component values with their sorry with their impedances. Second step is we convert all the circuit elements like resistor, inductor, and capacitor into their impedances RL, SL, and 1 over SC. This makes the circuit similar to the DC circuit where we represent resistors as their resistances. So this circuit we have represented all the elements with their equivalent impedances. So this makes the analysis easier. And the third step is apply KVL and KCL as required to find the transfer function. And finally, we apply KVL and manipulate these variables and equations to arrive at the transfer function. So these were the steps we followed while solving the above problem. Now let's study the two important circuit analysis techniques used in solving complex electrical network. In previous problem, we found out the transfer function of a circuit that involves manipulating a single loop. This circuit only has a single loop. However, in practical situation is more complex, involving two or more loops in the circuit. Under these situations, we apply two important circuit analysis technique, which are uh, one is mesh analysis, and the second one is node analysis. Uh, the term mesh is nothing but a loop which does not contain any other loop within it. So mesh is just a loop, but it is the simplest loop in which there is no loop inside of it. Uh, uh, Whereas the term node represent node is a point of interconnection of two sorry or more circuit elements. Uh, as there is a loop, we can say that we apply KVL while applying mesh analysis, and we apply KCL while performing node analysis. So I can write mesh analysis involve uh, applying KVL to find mesh currents, which in turn used to find the desired variable in the circuit. Let's make them bullet points. Mesh. Whereas in node analysis involves applying KCL at the node to find the node voltages, which is then used to find the desired circuit variable. So mesh analysis we apply KVL, and in node analysis we generally apply KCL. So now let's start discussing the mesh analysis technique. While applying mesh analysis, we execute certain steps. These steps are Mesh analysis technique. Uh, the steps involving the mesh analysis technique are: replace all passive elements. Passive elements represents resistor, inductor, and capacitor. Uh, uh, with their impedances. Second step is replace all sources and time variables with their Laplace transform. Third step is assume uh, transform current with direction. This is the important step in each mesh, as sometimes it is not marked in the circuit. So you have to assume the mesh current and its direction to apply the mesh analysis technique. Step 4 is write uh, KVL uh, around each mesh. Step 5 is solve the resulting simultaneous equations. Form the last step is form the transfer function. So these are the steps we apply while solving the circuit using mesh analysis technique. So let's do a problem related to it. Question is, given the network shown below, find the transfer function I2 of s by V of s. Circuit is R2, R1, V of t. This is the capacitor voltage C. This is I1 of t and this is I of t. Mostly the mesh currents are marked clockwise or anti-clockwise. So, but Once you have assumed the direction, all the meshes have the same direction. Here you can see this is a loop and this is a loop, uh, which does these two loops does not contain any other loop within it. However, this is also a loop starting from this voltage source R1 R2 C, but we cannot say this is a mesh since these two loops are inside of these bigger loops. So mesh is a loop which does not contain any other loop within it. Uh, so the first step is replace all passive elements with their impedances, and the second step is replace all sources and time variables with their Laplace transform. So first transform the circuit, transform the element values uh, to their impedances, and circuit variables to their Laplace transforms. The, the circuit in S domain will become resistor and inductor, again resistor, this is the capacitor. So this will become V of S, this will become R1, R2, this will become SL, and this will become 1 over SC. Vc of S. Direction of the current will remain same, but it will be transformed into the S domain. Uh, Now, fourth step is write KVL around each mesh. Then we will solve the simultaneous equation, and then finally we will form the transfer function. So apply KVL in mesh one. Uh, Apply KVL in mesh one. This voltage that the supply is giving to these elements is equals to the voltage drop across this resistor and voltage drop across this inductor. And then the enclosed loop in this mesh, we have only two elements. So the voltage drop across this resistor and voltage drop across this inductor will be equal to the source voltage. So I can write V of S, I am omitting this OS. V is equals to R1 I1 plus voltage drop across the resistor is R1 I1 plus SL. Since the this mesh current is going downward, if I am following this direction, and this mesh current is flowing upward, if I am considering this inductor, this current is I2 and this current is I1. So if I am assuming the net direction which is downward, I can write the voltage, the effective current flowing in this inductor is I1 minus I2. So SL voltage drop will be SL impedance multiplied by the current effective or net current flowing in the inductor, which is I1 minus I2. This will be equation number 1. Now apply KVL in mesh 2. Now If I am assuming the this circuit element is uh, feeding these two elements, then I can write the voltage drop across this is equals to voltage drop across this plus voltage drop across this, as these if I am combining these two elements, then I we can uh, just see the node the potential difference between this and potential difference between this and this will remain same, as this is the wire with zero resistance. So I can say the potential difference between this voltage drop across this inductor will be equal to the sum of voltage drop across these two impedances. So I can write KVL in mesh 2 as SL I1 minus I2 will be equals to R2 I2, which is the voltage drop across this resistor R2 I2, and 1 over SC I2 plus 1 over SC I2. This will become equation number 2. Now we have successfully applied the KVL in both the meshes. Now we will solve these two simultaneous equation to find the desired element, desired transfer function, which is I2 over V of S. As you can see, uh, we have three circuit variables, I1, I2 and V in both of these equations, and we have to find the Laplace transfer function which is relating I2 and V. So we have to omit I1 from these two equations. So I am uh, taking I1 from this equation, and will put the value of I1 in equation number 1. So from equation number 2, SL I1 minus SL I2 is equals to R2 I2 plus 1 over SC I2. SL I1 is equals to SL I2 plus R2 I2 plus 1 over SC I2, and I1 is SL I2 over SL plus R2 over SL I2 plus 1 over S square LC I2. Shifting this SL to this side of equation, so this will become SL and SL gets cancelled. This will become R2 over SL, and it will become 1 over S square LC. So I1 is I2 plus R2 I2 over SL plus 1 over S square LC I2. This will make our equation number 3. Now put the value of equation number 3, value of I1 from equation 3 to the equation 1. So put equation 3 in equation 1. We will get V is equals to R1 I1 plus I'm opening this bracket, R1 I1 plus SL I1 minus SL I2, taking I1 common from these factors, R1 plus SL, and putting value of I1 from this equation to this, it will become I2 plus R2 I2 over SL plus 1 over S square LC I2, and minus SL I2. Opening this bracket, V is equals to R1 into I2, R1 I2 plus R1 R2 I2 over SL, R1 multiplied with this factor and then R1 multiplied with this factor, plus R1 I2 over S square LC, plus SL into I2 plus SL multiplied with this factor, SL multiplied with this factor, SL R2 I2 over SL, plus finally this SL will be multiplied with this factor, SL I2 SL I2 over S square LC minus the last factor SL I2. Uh, Now do some cancellation. SL will cancel out each other, and this is plus SL2 and this is minus SL2, so they will cancel each other, and finally SL and 1 power with L. Now this equation will become V is equals to R1 I1 plus R1 R2 I2 over SL plus R1 I2 over S square LC plus R2 I2 plus I2 over SC. R1 I2 R1 I2 R1 R2 I2 over SL plus R1 I2 S square LC and R2 I2 and I2 over SC. So taking I2 common, this is actually R1 I2, R1 I2. Taking I2 common from all of these factors, V is equals to and taking LCM will become S square LC. So S square LC, multiplying this square LC with this, it will result in S square LC R1 plus S and L will get cancelled, SC R1 R2 plus this will become R1 plus S square, this will become S square LC R2 plus this will become SL. Now moving this I2 to this side of equation will result in V over I2 is equals to uh, making taking out S squared common from these factors and S common from these two factors, it will become LC R1 plus R2 S square plus R1 R2 C uh, plus L, this is actually C S plus R1 over S square LC. Now since we have to find out I2 over V, so I am shuffling these variables. So this will also get shuffled. This numerator will become denominator and this denominator will become numerator. Similarly for these values, so I2 over V is equals to S square LC R1 plus R2 S square plus R1 R2 C plus L S plus R1. So this is the required transfer function. So this was a, a problem related to the mesh analysis technique. You can see we have applied all these uh, 6 steps to solve the circuit using mesh analysis technique. Now let's move towards the node analysis technique. First we will define the steps required to solve a problem using node analysis technique, just as we did for node analysis technique. So node analysis technique. Steps to solve the node analysis technique. Solve a problem using node analysis technique. First step is replace passive elements with their impedances. This step is same as for mesh analysis technique. Second step is this step is again the same. Replace all sources and time variables with their Laplace transform. Step 3 is different. In mesh analysis, we mark mesh currents. Now here we will mark node voltages. Mark node voltages at each node with respect to reference node, also known as ground node. Step 4 is write KCL. In mesh analysis technique, we wrote KVL, but now in node analysis technique, we will write KCL equation at each node. Step 5 and 6 are again same. Solve the simultaneous equation for output. And step 6 is form the transfer function. So these are the 6 steps we will follow while solving a problem using node analysis technique. Let's do the same problem as done previously using mesh analysis technique with now the node analysis technique. Question is find the transfer function Vc over V of s for circuit shown below. So I am redrawing the circuit. Uh, Circuit is voltage V of t, resistor and inductor R2, capacitor C, R2, L, R1. Now we have to find the transfer function that relates Vc of t and the source voltage V of t, of course in S domain. In previous problem, we found out the transfer function relating this mesh current I2 with this source voltage. Now we will apply all these steps to solve this problem. Now it seems that the time of the lecture has ended, so we will continue from here in the next lecture. Thank you very much. Allah Hafiz.